Hello, my dear students. Okay, so we have studied electrostatic electric potential energy. Now, today our lesson is electric potential energy due to a dipole. Okay, so electric potential energy due to a dipole. Okay, so that dipole is placed inside a uniform electric field. So look at here. So it is uniform electric field, that means parallel and equispaced line, parallel and equispaced, parallel and equispaced, parallel and equispaced. Okay, here there is a dipole making an angle. There is a dipole making an angle of theta. Okay, let us take another color. Okay, so let us consider this is the dipole. Okay, minus q, and here it is plus q. Okay, the angle with the electric field is theta. Okay, so now if we move the dipole inside the electric field, movement means torque will come into act. Okay, if you move the dipole inside the electric field, then we have to do certain amount of work, and that work is stored as potential energy. Okay, so consider here. This is theta 1 man initial, and now this is the new position of the dipole, minus q plus q. Okay, here it is. Okay, here it is minus q, here it is plus q. So movement is made by application of torque, and so a small displacement of angular displacement, that is d theta. So small. Now let's approach the derivation. So a small angular. Okay, so potential energy, electric potential energy of a dipole electrical potential energy of the dipole is the work done by external torque through angular displacement d theta. So work done by external torque through angular displacement d theta. Let us find out this first. So work done is equal to tau d theta. So this is the small work done. For small angular displacement, there will be small work done. So W is equal to tau d theta with integration. Integration vary from theta 1 the initial, theta 2 is the final displacement, angular displacement. Okay, equation 1. Let's move to the next page. We know tau is nothing but angular rotational torque, and that is the what is that? Let us consider. Here it is. This is minus Q, this is plus Q. Okay, so this is the force QE in this direction as the electric field direction is in that direction. And here it is the force minus QE. Okay, net force is 0. So either of the force and perpendicular distance. So perpendicular distance is this one. So this is 2a. So here it is 2a cos theta. And here it is 2a sin theta. So tau is equal to QE 2a sin theta. Understood? That implies Q2a is P. So PE sin theta or P cross E. So torque is nothing but P cross E. So is equal to PE sin theta. Torque equal to magnitude of the torque equal to PE sin theta. Okay, equation 2. Putting equation 2 in equation 1. What we get? We get work done. Okay, work done. Work done tau d theta. Work done is equal to tau. Tau is PE sin theta, then d theta. Integration vary from theta 1 to theta 2. Electric field is uniform, so it will come outside. P is constant because minus Q plus Q are the charges and distance between them will unaltered. So P and E coming outside. Sin theta d theta. Integration vary from theta 1 to theta 2. Integration vary from theta 1 to theta 2. So PE sin theta integration minus cos theta formula. Okay. So lower limit theta 1, upper limit theta 2. Let's move to the next part. So minus is taken outside of the expression. So W is equal to minus PE, and that cos theta is becomes cos theta 2 minus cos theta 1. So this is your final expression of the dipole potential energy, equation number 3. Okay. So if dipole is perpendicular to the electric field, is the mean position, is the or initial position. What does it mean? Theta 1 is equal to 90 degree and theta 2 is equal to random theta, any angle. Okay, so that means originally electric field, if the dipole is placed perpendicular to the electric field, and after the movement a theta will be made. So that what is the amount of work done? That has to be calculated. Okay, so putting the above condition, in equation 3, what we get? So W is equal to minus PE, cos theta 2 is cos 9, cos theta 2 is cos theta, and cos theta 1 is cos 90. Okay, so cos 90 is 0, so rest is minus PE cos theta. So this is the another formula of potential energy of dipole, but condition applied. The dipole is placed perpendicular to the electric field is the original position, is the initial position, right? So now let's consider few cases. So special cases to it. special cases. So write with a better color, special cases. Case number 1. What is case number 1? Work done is that much. So work done is nothing but potential energy is equal to work done. So is equal to minus PE cos theta. That means potential energy is equal to minus P vector dot E vector. Isn't it? This is equation number 5. So this is the concise formulation. Potential energy of a dipole is minus P dot E, or dot product, negative product of, or minus of the dot product of dipole moment and electric field. So case number 1, what is that? Now if the torque is applied to the dipole from its initial position to the position parallel to the electric field. Parallel to the electric field. That means here is the figure. It is the position, and now minus QQ plus Q. Now it becomes like this. Change the color. That will be betterly understood. Okay. Now this becomes here like this. Now it is parallel to electric field, minus Q plus Q. Okay, parallel to electric field. Here it is plus, here it is minus, as electric field is always along the direction of, is always coming out from positive charge and ending at or terminating at negative charge. Understood? So this is the dipole position, the final position. So here the angle made is, final position is theta equal to 90 degree. Isn't it? Or what? PE cos theta means angle between P and E. Isn't it? Angle between P and E. So theta is equal to 0 degree. 90 to 90. 90 to coming back to the parallel position. That means, what is that? Dipole moment P is parallel to electric field. In this case, potential energy is equal to minus PE cos 0, and cos 0 is 1, so minus P. And this is the minimum value of potential energy. That means body is not stable here, minus PE. Okay. Now let's move to the case number 2. Case 2. Case 2 is when theta is equal to 90 degree. That means original position. Original P, and that means P is perpendicular to E. That means original position. Original position, then there should be no work. Okay. So U is equal to, formula is also suggesting the same, P cos theta. Cos theta is cos 90, so is equal to 0, as no work is done. Understood? So now case number 3. So case number 3 is theta is equal to 180 degree. That means anti-parallel. So P vector is minus E vector. That means here it is. So here the electric field. Okay, it is the original position. Now change the color. Okay. So here it is. So here is, it is minus q, it is plus q. So it is plus q, it is minus q. Okay, reverse. Okay, so theta is equal to 180 degree. So in this case, u becomes minus pe cos 180. Cos 180 is minus 1. So minus pe into minus 1 is equal to p, which is maximum value of the potential energy. Understood? Understood? So now let us talk about stable and unstable equilibrium. Okay. So condition of stable and condition of stable and unstable equilibrium. What does equilibrium means? For stationary state, for linear equilibrium, force has to be zero. For rotational equilibrium, torque has to be zero. So in which cases these two happens? So let's consider stable equilibrium. So draw the diagram. So here it is. Here one condition. Here another diagram. Electric field. Here another condition. Here electric field. Okay. So here the condition one, when, okay, here dipole is minus q plus q, theta is equal to 0. Here is minus q plus q, theta is equal to 180 degree. Okay. So here tau is equal to P sine theta, sine 0. So it is 0. So tau is 0. Here is also 180 means sine 180 0. So F is 0, tau is 0. So which is the case of stable, which is the case of unstable? For stable equilibrium or for unstable equilibrium, we have to apply certain condition. We have to apply external torque. So I am putting this in external torque and moving it to like this. So here it is plus, here it is minus, because electric field originated from electric field initiated from plus and destined, or it is terminated at negative. So minus q, here it is plus q. So such movement is done by applying external torque. So minus charge is moving away from positive charge, but negative charge is directed from minus to plus. That means negative charge wants to be here, means this is the condition. If we remove the external torque, it will come back, because negative charge 6 positive charge, and positive charge, here it is negative charge, here it is positive charge. So positive charge 6, negative charge. So just after the removal of the torque, it will come back to its original configuration. That means here equilibrium is stable. Stable equilibrium. Understood? Stable equilibrium. Okay. In this case, if we move by applying external torque, then it is plus, it is minus. Then plus is moving away from plus, then it is good, because it is repulsive force. There will be a repulsive force in between. So it will try to continue its torque. Even if the torque is removed, the motion will continue, and the thing, it will be distorted. That means original configuration is not regained, and this is the case of unstable equilibrium. Understood? So just write it down, 2-3 sentences. Okay. So when theta is equal to 0, the equilibrium is maintained even if external torque applied on it, but it regains its original configuration just after the removal of it. This is the case of stable equilibrium. Understood? Now, when theta is equal to 180 degree, that is P is anti-parallel to electric field. So what happened? When an external torque applied to the system, the dipole tries to continue its rotation even if external torque is removed. Okay, external torque is removed. Thus complete distortion of dipole occurs. Means position. Okay, this is the case of unstable equilibrium. Hence this is the case of unstable equilibrium. Hence this is the case of unstable equilibrium. Okay, this is stable equilibrium, this is unstable equilibrium. Understood? Okay. So in the next class we will study few numericals to understand the facts and concepts more vividly. And on the next class we will enter into the chapter of capacitance. So I will thoroughly complete each and every part of it. So complete 12th class learning will be possible by viewing my videos. So just go through that video and enjoy the learning of physics. In this COVID situation, the learning should not be ceased. If you want to personally study with these type facilities with all type of numericals and every caring things, then you can contact me with my mobile number 8917375 Okay, good night, take care, bye bye. Himanshu sir, rest this session.